Before we move on, let's make sure that you're studying and retaining this information. As we cover a lot of information, it may seem simple in the video, but until you're testing yourself, you don't always know. So think about first law of thermodynamics, the second law of thermodynamics, the HVAC version. What affects the speed of the second law of thermodynamics? What is refrigeration? And then draw your refrigeration cycle. Remember to use red and blue marking devices and start with the compressor or one component and go in that same flow. Don't skip around, flow how the refrigerator is going to go. So pause this video right now and test yourself. Welcome back. Let's see how well you did. What I want you to do is leave the example that you already did in front of you. And I want you to start a new one, and we're going to do the whole refrigeration cycle together. And it's going to be a little bit slow, a little bit painful. We're going to go through all these details together, and I want to help connect these. So the more that you draw this out, the more that you do this at home, the faster you're going to retain this information. Nobody likes rewriting stuff, and I tell you the power of writing is very, very important. So let's get started. First, I'm going to start off with an inside unit and an outside unit. So I'm going to write over here inside. So this is my indoor unit. On this side is going to be my outside. So very simple there. And we're going to start a refrigeration cycle with the easiest thing to find, and that is going to be our compressor. So I'm going to draw my little symbol for compressor, and we know that it's commonly called a compressor. And it has two names, also called and I want you saying these words before I say them, physically say it out loud. Hopefully nobody's around to laugh at you, but I want you physically saying these words because it's going to help you with the learning process. So it's compressor, also known as hopefully said, vapor pump. And it doesn't matter that you can't see these words. I'm wanting you to practice along with me. As you write this stuff down, you can pause at any time, write this information down, rewind and hear it again. But it's a compressor. It's also known as a vapor pump, and it does three things. It sucks low pressure vapor, and it pumps high pressure vapor, and it moves the refrigerant. So when you draw the compressor, when you draw this little symbol, however you want to draw your compressor, I want you in your mind picturing an actual compressor. I want you having this in your mind, thinking about it. So when you're drawing this is what you're imagining. Now when you see this, I want you thinking about the refrigeration cycle and thinking about all of these things. That way they're connected. It's not just that we're practicing drawing this for fun. I want you to understand that as we draw this symbol, it's this component. When you're looking at this component, you're thinking about these things. So you draw that first and you're connecting it all together. Now we're going to get our red device. This represents high pressure. And this little bitty short line, the shortest line in the whole system, is going to be right here next. This little line, we're going to draw it in red. And remember, this component has two names. They are the discharge line. And it's also known as a hot gas line. And the state of refrigerant in that line is a high temperature. So I'm going to abbreviate HT, high temperature. And it's a high pressure. I'm going to abbreviate HP for high pressure. And it's a superheated vapor that we're going to learn about next, or soon. And we're going to put an arrow so that we know it's coming away from the compressor. And our next component is going to be this condensing coil. So we're going to know that we're going to be rejecting heat. This is our condensing coil. So whatever you need to do when you're seeing us draw this condensing coil, I want you picturing this coil. And when you look at this coil, I want you picturing what we're drawing right here. So they are the same. They're not different. And we're going to go back and forth to represent the refrigerant flowing back and forth across that condensing coil. And then we're going to label this condensing coil. And the other thing this condensing coil does, we got to remember, it rejects heat. It's giving up heat, it's rejecting heat. So we're just going to write rejecting heat. We're going to add more to that, But right now, just getting those simple things, getting that connected. So now that we've pictured this condensing coil, we're also now going to picture our liquid line. The liquid line is leaving the condensing coil. That liquid line is going to connect the outdoor condensing unit to the indoor unit, our metering device. But that liquid line, the small line, it's more like a 3/8 line. If you look at the units, there's a bigger one and a smaller one. It's going to be the smaller line. It's still going to be red, still going to be high pressure. This is where we're going to use our high pressure gauge. And what I want you to do also is don't forget this little guy here. This is called we're going to draw it, I'll just draw it here in the middle. It can be anywhere in this line, but it's called a liquid line filter dryer. And it's going to have an arrow on it, and the arrow is floating away from the condenser, and that arrow is flowing towards our metering device, or towards the indoor unit. So remember, this got to be changed anytime you open up the system. In this case, it's right here, leaving the condensing coil. Another case, it could be right here before the evaporator coil, or anywhere between, as long as it's on the liquid line. It can never be on the hot gas line. It should never be there. So we got their next component, and now we're going to change to our black marker, because this component is a symbol. We're going to have a circle with an X through it. That's the symbol for our metering device. So when we draw a circle with an X through it, I want you physically picturing one of these kinds of metering device. Whichever one you like the most, I want you picturing it. I want you connecting it. And we know that metering device has two names. It is a metering device. We're going to write that down together. Metering device. And it's also called an expansion device. So this is a thermostatic expansion valve, but it's still an expansion device. This one's a fixed orifice expansion device, and this one's also a fixed expansion device. But they are all expansion devices. They're all metering devices. Now that we know both the names, let's talk about what's happening. What this is doing is going to restrict the flow from a high pressure, and I'm going to abbreviate HP for high pressure, restrict the flow from a high pressure liquid. High pressure liquids coming in, high pressure liquid, to a low pressure. I'm going to abbreviate LP for low pressure, and this is the key word we're going to talk about soon, saturated mixture. And on the other side, we're now going to have a low pressure. So we're going to have low pressure coming out of this, and coming out of this metering device, it's going to be approximately 75% liquid and 25% vapor. There's going to be liquid and vapor together. With the metering device has caused the pressure to drop, so our temperature drops, 75% liquid, 25% vapor. Now we're going to go straight from our metering device right into our evaporator coil. Our evaporator coil is low pressure, blues that low pressure, and we're going to be going back and forth on the indoor unit, and this is representing the evaporator. So we're going to write evaporator. And ultimately, there's a lot more we're going to add to this. There's a lot more we're going to learn about this. But ultimately, the job of the evaporator is to absorb heat, to collect that heat. So it's going to absorb heat. If I absorb the heat out of the air, it's going to go into the refrigerant. You're cooling the air off or taking heat away from the air. That's what's happening. The heat has to go somewhere. We can't destroy it. It's going into the refrigerant. So now that we leave our evaporator, we're going to have our suction line. That's going to be this big line, the thicker line. Usually has insulation on it, like this example. It's going to go all the way to the outdoor coil through a valve. It's going to end up all the way back to the compressor. So we have a complete cycle. But it's not just called a suction line. It's also called a gas line. Suction line, or simply a suction gas line. The state of refrigerant in this line is extremely important. It is a low pressure, LP, low temperature, LT, superheated vapor. We're going to talk about that superheated vapor later. You're going to have to hang on because I'm not telling you just yet. It's a low temperature, low pressure superheated vapor. And what we're going to do is put our little arrows on here so that we know we now have a full and complete cycle. It's very important you put all of those words together. You connect all this. This is the reason I draw my refrigeration cycle, is because it helps us see the inside versus the outside. The metering device is typically with the evaporator. The compressor is typically with the condensing coil. They are together as a complete cycle. It really doesn't matter where you start as long as you come back to that point. I prefer to start with the compressor, but wherever you want to start from that component and then go in order all the way around. Don't skip around. I know a lot of people want to, but with the learning process of understanding this, and as we're going in the future, if you do it in order, it's going to help you out tremendously. Redraw this however many times it takes. Now, if you're in another school, people draw this all different kinds. When I went to school, we learned it as a compressor, and the metering device was below it. And then we learned we had, as a circle, we had our condensing side, and on the other side, we had our low pressure to evaporator side. And it's still the same cycle. We have our compressor, condensing coil, metering device, low pressure, evaporator, back to the compressor. It's still a cycle, but it never really said how everything was in the system. So by drawing it this way, you can actually start to see the metering device and evaporators inside, the compressor and condensing coils outside. Notice I've said that many times because I see a lot of students get that mixed up. They get mixed up where it's going to be. A lot of students will want to draw the metering device way over here in the middle. Well, my metering device isn't over here. It's actually in the same housing as the evaporator coil. If we look over here, this one's right here in the same housing, and this one is as well. It's right here in this component. So study this, practice this. Before you move on to that next video, make sure you have this down. Draw it in color with the arrows, and the next videos we're going to add to this, and we're going to add to this, and we're going to add to this, and eventually we're going to get you understanding HVAC all the way through with a solid, firm foundation.